Good morning, Doctor. I'm Brandon Chan from Section 2 of Computer Organization and Architecture. So today, the tools that I will be explaining on is Cinebench 2026. Right. Right, so for workload A, what we do is we change the minimum test duration to 30 minutes to test stability. After that, we just press the start button beside the multiple threads and we wait for 30 minutes and the results will be out. So moving on, here is the log file for workload A. So the things that I had paid attention inside this log file uh, is the score that is obtained from running each workload. So more of the score will be explained later. So all right. So here is the analysis and findings that I had found from the log file. So first of all is the empirical findings from the log file. We can see that from the log file, the final multi-core Cinebench score is 2038.873719 points. Then the peak multi-core score, CB CPU X peak, is 2044.758245 points. Then the single core score is CB CPU1, which is 0. Peak single core score 0. Single core score array is empty. So the single core score is either 0 or empty is because the workload is explicitly configured to run a multi-core loop. Therefore, the single core metrics will completely bypass. So things to take note is that the CPU execution time TCPU is ran for a total of 1800 seconds, which is the 30-minute test stability times with 60 seconds. Then the task level throughput, which is the time taken to finish each of the tasks, is about 30 minutes divided by 4 tasks, which is 7.5 minutes per task. Then moving on, I'll be talking about the pipeline saturation efficiency. So before we do that, let's see the CB CPU X array, which is the multi-core score array. So we can see that from the first iteration, it is 2044.758. Second iteration, 2031.366. The third iteration, 2025.721. Then the fourth iteration, 2053.650. So within the computer architecture, multi-threaded workloads increases the temperature of the CPU and usually pose a threat to thermal throttling. This thing can cause clock speed drop and a decrease in execution performance. But then on the other hand, it is observed that there's no decreasing trend of the data related to workload A. But on the contrary, the best result obtained is the last iteration, which is 2053.650 points. Well, this facts actually demonstrates that the high level of optimization regarding the pipeline saturation and thermal efficiency of the Apple M2 efficient architecture. So moving on, I will be explaining about the workload B. So for workload B, it's the same thing as well. We change the minimum test duration to 10 minutes, then press the start button beside the single thread. Then we just wait for 10 minutes and the results will be out. So here is the log file for workload B. The things to notice as well is also the score obtained, which is the score obtained for the single core. So here's the empirical findings of it. So we can see that the multi-core score is 0 for every multi-core, and it's observed that the single core had achieved a point of 442.533. Well, this actually proves that the system actually runs on a single core and not a multi-core. Then we can see that uh, from the single thread pipeline efficiency. So a score of 442.533 actually shows that it is very efficient. The Apple M2 achieved this efficiency because of structure optimization and not due to increase of electrical power or clock scaling. This is because the design actually enhances the efficiency of processing per clock tick and actually perform significant processing operations while maintaining efficiency of power consumption. Well, then the maximum boost clock and intermittent core shifting. So a 10-minute heavy rendering task can actually cause a lot of heat to generate on the processor. Therefore, in order to maintain a high performance, intermittent core shifting is used. So while the test only use one core, the processor actually dynamically moves the active workload across the array. By seamlessly transferring the execution thread to a cooler core, just as the active core approaches its thermal limit, the system effectively prevents thermal throttling and allows the processor to sustain maximum boost clock frequency throughout the entire duration of the test. This resulted in a stable, high performance score which is generated in Cinebench. So, yeah, that's all for my presentation, and thank you.